Okay, now we are going to find the partial sum of an infinite arithmetic sequence. We are given the first n terms and nothing else. So our challenge is going to not only find the a sub 100 or the 100th term, but we need to also incorporate and define what the pattern is in the sequence. So if you recall, for s sub n, we do need to find both the first term and the nth term. In this case, it's 100. So we know the first term. We just now need to find what the 100th term is. So the first step in defining a sequence, let's find the common difference, and that is 2. That is the common difference between each of these numbers in the sequence. And we go ahead and use the formula of the first term plus n minus 1 times the common difference. And in this case, where n is 100, our first term is 1, which makes n minus 1 99, times the common difference, which equals 199. And that checks out to what we had done before. So a sub 100 is 99. But we are looking for the sum of the terms all from 1 to 99. So we need to use our new equation of s sub n, and n is 100. So I'll just go ahead and denote that. Wherever I see an n, I'm putting 100. We know our first term to be 1 and our last term as 199. And crunching out the numbers, the sum of the first 100 numbers of the odd numbers, the 100th partial sum, is equal to 10,000. Okay, so let's find the sum of the first 15 terms of the arithmetic sequence, 3, 6, 9, and 12. So I'd like for you to go ahead and try that, the example number 10 for the got it question and the got it number 11, using the same method of defining first your common difference, finding the term at the end, and the summation between the first term and that a sub n, whatever it is asking for you to do. So go ahead and pause and complete those. And when you're ready, let's go ahead and solve example number 12. So here we are asked the same thing, except now I'm using decimals. And the first thing I'm going to do is I'm going to see what that common difference is. And in this case, I am adding 0.8 to every single term, so my d equals 0.8. I'm going to need my last term to be a sub n, so I can go ahead and write the formula for finding the next term, which is a sub n, 0.5, plus 10 minus 1, which is 9, times my common difference of 0.8. Okay, and when I calculate that out, my 10th term is 7.7. So now I can go ahead and set up my summation formula to find the sum of all of the sequence terms up to 10, and I have 10 of those, and divide that by 2, times 0.5, which is my first term, to a sub 10, which we just calculated out. And if I go ahead and calculate that out, s sub 10, where the summation of those first 10 terms, equals to 41. So we have got it number question 13. Go ahead and complete that. We have a brick patio which has the approximate shape of a trapezoid. We are given the first and last number of bricks in each row. So please go ahead and complete that and then move on to page 12, where we have our final problem with example number 14, which will sum up this entire video. Okay, to sum it all up, we are going to go through everything that we've pretty much learned about arithmetic sequences and the summation of that sequence. So we are asked to find the general term given the starting point of a sub 1 and the common difference. So let's go ahead and recall that a sub n, the general term formula, is the first term plus n minus 1 times d. This is the explicit formula in terms of n, and there is no a sub n minus 1, which is the recursive formula. We're not dealing with that right now. If we go and plug in our values that we are given, our first value is 5, and then we have n minus 1 times our common difference of negative 4. Okay, and we are also, that is the formula for the general term. I can also write this as another explicit way. I can go ahead and distribute this negative 4 into each of those values, and I end up with the same, it means the same thing, negative 4n plus 9 if I go ahead and distribute that. And this value right here, this is RC. It is the first term minus the common difference, which is 9. And this is also another equivalent way of writing our explicit formula. So you can use either this method or the alternate right here. And that is number 1. We have found our general term. We are going to use that general term to find the first n terms. And I choose to use the equation on the right, negative 4n plus 9. So I'm going to go ahead and write out the terms that I'm looking for all the way up to a sub 5. And you can see the pattern readily available here. If I went ahead and said, well, a sub 1 is negative 4 times 1 plus 9. Then for a sub 2, I have negative 4. I don't know why this isn't working so well. Times 2 plus 9. Negative 4 times 3 plus 9 is the third term in my sequence. And negative 4 times 4 plus 9 is the fourth. Negative 4 times 5 plus 9 is the fifth. Okay, and when I compute all of these values, I end up with 5, 1, negative 3, negative 7, and negative 11. We can use the same format, the same explicit definition to find a sub 100. We are going to need that to find the summation of the first 100 terms of our sequence. We are given the first term, so that is easy, but we're going to need to go ahead and calculate a sub 100 out. So I have negative 4 times 100 plus 9. Okay. And that equals to negative 391. So I can go ahead and plug this into my formula. I already know my a sub 1. So my summation of S100 is 50 times 5 minus 391. And when I punch that out, the summation of the first 100 terms, if everything checks out correctly, is negative 19,300.